So the next talk is from Gautam Arvind Pandian and Vikas Gupta, and is called Perils of Running Apps in Android Virtual Containers. Gautam is from Thales Group and is a security researcher in the field of mobile applications, and in the past supervised development of applications dealing with very sensitive data in the banking and governmental sectors. Vikas Gupta is going to start this talk. He's a security researcher and penetration tester focusing on mobile applications. He's also one of the top contributors of the OWASP Mobile Security Testing Guide and involves himself a lot in reverse engineering, which can be a lot of fun. They were going to talk about the pitfalls of running application in Android virtual containers, and please welcome Vikas Gupta. Please enlighten us with your talk.
All right, so is my slides visible?
Your slides are perfectly visible, yes.
Okay, great. So firstly, thanks to the organizers for organizing this virtually. All right, so let's get started. So today's talk is about perils of running apps in Android virtual containers. And okay, let me get this full screen first. Okay, yeah. So the agenda for this presentation. So we'll start with an introduction, what Android virtual containers are. Then we'll talk about the use case and the current market status of these applications. We'll look into how we can attack an application running inside the virtual containers. Then we'll move on to how we can detect these virtual containers. We also have some recommendations for the developers to ensure security. And then we'll have some points for discussion and conclusion. So a quick word about us. So myself, Vikas Gupta, I've been working with Thales DIS India, and I have been actively contributing to OWASP MSTG, and I have interest in reverse engineering and obfuscation. Gautam? Your audio is not. Yeah.
Okay. Okay. Hello, I'm Gautam Arvind Pandian. I work as a security researcher and security architect at Thales DIS Singapore. My interests are towards crypto and the hardening of mobile applications.
Okay, thank you, Gautam. So let's get started. So what are Android virtual containers? So these are innovative application level virtualization frameworks. So you can relate that there is a host application, which is an Android application. And then this host application will be running multiple guest Android application inside it. One important thing to note is that these guest application does not require any explicit installation. Also, the added advantage is that you can have a second instance of any desired application running on your device. The guest app can act as this second instance. And we'll see in this presentation that when you run an application, a guest app inside virtual container, it kind of reduces the security overall. So to visualize over here, I have a parallel space app installed on my device, and you can see there are multiple apps installed inside the parallel space app. So these are the guest apps on the right-hand side. You can see I have two instances for an app called Ola and Uber, and that's basically the use case for such kind of virtual containers. So the first work, the most important work was done and presented in Black Hat Asia 2017. They provided a very detailed description of how these Android virtual containers work. They also gave some examples about how it has been actively exploited by malwares. And they also proposed some ideas how to detect and kind of stop your app being used as by malwares, basically. One thing I would like to note is that we personally didn't find the use of the term Android plugin slightly confusing and not descriptive enough. So in this slide, we use the terminology virtual container. Okay, so some of the apps which are available on Google Play Store, and where can I get one? So two important projects are Virtual App and Android plugin. They are available on GitHub. They are open source, so you can always go and build your own applications, virtual containers. Then the most famous one is Parallel Space app, which is having more than 100 million downloads. Then there are other applications as well, which are pretty famous. And you can see from the number of times they are downloaded that for sure there are easily millions of users using this kind of environments. Another case is OEMs providing a way to run multiple instances of application. One such case is OnePlus Devices. It's important to note that OnePlus Devices are not using virtual container approach. Instead, they create a new Android device internally, and then they run the second instance of these apps in the context of this new Android user. So some of these applications which are supported by OnePlus Devices are messaging apps like WhatsApp, ride-hailing apps, digital payment apps, and they have a huge list of Chinese apps. So overall, there are 56 hard-coded applications inside the OnePlus Devices which are supported. Another vendor supporting this is Xiaomi, and they market it as dual apps on their platform. So it obviously raises a question, is there a really need to running multiple instances of an app? So in our research, we find that for sure there is a need, especially given that the prevalence of dual SIM devices now. So every user predominantly have dual SIM devices these days, especially in Asian countries, and which kind of makes a need to have two accounts, one account associated with each mobile number. For example, I want to have two WhatsApp accounts or maybe two e-commerce accounts to get different kind of deals. Some accounts have different deals. Another need is to have a separate personal and business applications on one device. Another case is to run games, which is very helpful when you want to tinker with the games and you don't want to root your device. So there are already tools available which can help you if you have the games installed inside the virtual containers. So a quick understanding how these virtual containers work. So these virtual containers are using technologies like Java Dynamic Proxy API and Reflection to create a virtual environment on top of and transparent to the Android framework. Using these technologies, you can kind of hook into the APIs and regulate the life cycle of the application, of the components. Another important thing is that you
I'm sorry, we can't hear you. Maybe you muted your microphone.
Maybe I think he has some network problems.
We cannot hear. Disconnected from his side.
Okay, there seems to be a problem. Okay, just a minute, we try to resolve that.
Okay, can you hear me? It seems the Murphy law has hit me.
Yes, we hear and see you again.
Okay, all right, let me try to present again then.
Okay, please.
Yeah. Okay, sorry for that. So starting again. So I have a diagrammatic representation how virtual containers work. So over here, you can see that I have 3 guest applications, app 1, app 2, app 3, and all the various calls for these guest applications will be going through proxy hooks, which was implemented using reflection and other Java techniques. You can note that all these calls will be going via host app, and then the host app will be interacting with the Android framework. So for the Android framework, the presence of guest app is totally transparent. In fact, it doesn't even know about their presence. Okay, just to summarize, so three important things with these virtual containers is one is the shared UID. We'll be talking a lot about this in detail as well, but all the guest apps installed inside the virtual container tend to share the same UID. It has various implications. And then secondly, for the management of the permissions and various subcomponents and the various application components which are there for the guest apps, it's kind of the host app predefines them, and then they try to use these predefined components. Similarly, the host app takes care for the component lifecycle management, whether it is the services or broadcast receivers or other Android components which are there. I highly recommend that if you want to really understand the detailed workings, to check out the Black Hat paper, although we don't need to understand all the details for this particular presentation. Okay, so now just a quick refresher of one important information, that in Android, whenever an application is installed, it gets a unique user ID, and it also is assigned a directory owned by the application. This uniqueness of the UID, which is assigned to the application, is responsible, or which is used a lot for various security mechanisms. And yeah, we'll discuss them pretty soon. Okay, so if we look at the Android documentation, there are 6 core points which are listed, which talk about the various core security offered by Android. And if we go through them one by one, we'll see that out of the 6, 4 of them are really not applicable in case of a guest application or an application running inside the virtual container. The 2 points which are not broken by these virtual containers are way below their abstraction layer, like presence of ASLR or DLmalloc or Kellogg kind of functionalities. And similarly, the encryption of the file system. So there are many mechanisms in Android which are dependent on the UID. For example, application permissions, Keystore, Android ID. Some other Android security mechanisms which are broken is unauthorized access to the other guest app sandbox data. A guest app can get the listing of the other running guest apps or even the installed apps. So let's have a look on each of these attacks one by one. First is the Android manifest permissions. So the problem is that the guest apps are not really installed in the virtual container. And because of which the manifest file is not really processed. So whatever permissions a guest application requires, the host application or the virtual container kind of need to pre-guess it. So what they do is they blankly ask for all the permissions which can be possible. So in case of Droid plugin application, 141 permissions are present in the manifest file. So once an application, or once this one permission is granted, it will be available for all the guest applications. So this raises a major privacy concern. And also, let's say if one guest application which primarily needed this particular permission is deleted or no more used, still the other application will be having access to this permission. So this is a major privacy concern in terms of overall various guest application installed inside the virtual container. Another privacy concern is with the listing of the various other applications inside the virtual container. For example, you see the screenshot on the top. I'm listing various installed applications inside the virtual container. And in the bottom screenshot, you can see various running applications at the given point of time in the virtual container. From API 22 onwards in Android, such kind of listing of running apps was disabled, but yeah, inside the virtual container, it is still available. Another example is the sandboxing of the app data. So over here, you can see that on the left-hand side, the apps which are running inside the virtual container can access the sandbox data of each other application. We'll try to demonstrate the implications using a demo as well. But before that, a quick intro about the Android Keystore. So I think most of us already know that Android Keystore is a secure system level credential storage. In modern Android devices, it is hardware backed, and previously it was implemented in software as well. And the overall security of the Android Keystore again depends on the UID of the application. So to understand it diagrammatically over here, I have a virtual container application with 3 guest apps. and one key associated with each app inside the Android Keystore. And you can see that each key will be accessible from the other guest application. So basically, there is no segregation of these keys. Such kind of vulnerabilities were there previously. Like in 2014, there was a vulnerability of key leakage between the security domains, which was fixed in Android. But then these kind of things are still available in virtual containers. So on the demonstration part, so we took up an application called AndOTP. It's a 2FA application for generating TOTP and HOTP tokens. Yeah, we are using this application. The application inherently does not have any vulnerability, but when we look into this demo, we will realize that how a vulnerability can be introduced when we are using an application inside the virtual container. A quick idea about what we are really looking at in this AndOTP application. So this AndOTP application provides a functionality where you can encrypt the data backup. So you have the OTP seeds and other related information, critical information, which is needed to generate the OTP information. So you have an AES key K, which is generated using the user provided generated diagrammatically that malware is present inside the virtual container. It will have the
Vikas, we can't hear you clearly.
There seems to be a problem with your internet connection. May this be the case? Okay, once again, we try to resolve that issue. Please stand by.
All right. This has to be the and then
Okay, because I'm sorry to tell you, it still doesn't work. We don't yet see or hear you.
Okay.
Am I audible? Hello?
Oh, yes, that looks much better.
Yeah, this is horrible. I'm really sorry about it. I have no idea why it's happening now. Okay, anyways, I'm almost done and then I can hand over to Gautam. So let me just quickly share the video. So I have a small demonstration about how I attack the AndOTP.
Sorry, could you possibly go back 1 or 2 slides, because
okay, sure,
it was a short time frame where we weren't sure if it will work again.
Okay, let me try it. Yeah. Okay, so I was over here where talking about that if a malware is present inside the virtual container, it can get access to the RSA key pair, which is generated by AndOTP application for backing up the data. And it will also have the access to the OTP key and the secret data, the 2 files which are backing up the information. Okay, moving to the demo. So over here, I have this virtual container, which I have multiple applications installed. I'll be attacking AndOTP application. So I have the and OTP working here. I'm entering the user, and over here you can see that A31. Okay, now I have another malware application which will be attacking this. And you can see that I am able to generate the same OTP over here.
Okay, because once again, you were cut off. I think we don't hear audio. We do see the screen, but we don't hear audio.
Okay. Okay. I think Vikas has some network issues.
Yes, I guess so.
Okay. So I'm the next speaker, so I can maybe take over.
Yeah, perfect. This seems to work. Thank you.
Okay. Okay. You're seeing my screen, right?
Yes, we see your screen. Yes.
Okay. So to just reiterate what Vikas was mentioning, so he was mentioning that if a malware is present in the same container as and OTP application, so the malware can actually access the RSA key which is inside the keystore, and using the RSA key pair, he will be able to decrypt the OTP seed itself. So once you have the OTP seed, which is the primary asset, then the malware can actually generate OTP at will. So this is the point which we were trying to show in this demo. Okay.
I'm sorry to interrupt you. It seems that your screen is frozen.
Okay.
You try to make it full screen and then it just seemed to be frozen. We can hear you.
Okay. Okay. Right.
Yeah. Yeah. Okay. No, I think the very same thing happened. It simply did not switch to full screen.
Okay. Okay, fine.
Once you started full screen, it freezes.
Okay. Let me keep it like this. Is it fine?
Yeah, that's perfect. We can read it well.
Okay,
Thank you.
cool. Okay. So the next part of the talk is about the pen testing environment. So generally, virtual container can actually provide a good pen testing environment. So when we researched into this virtual containers, we wanted to check what are the attacks possible from a host application onto a guest application. So while researching that, we found that besides permissions and other attacks, so we found 4 more attacks that is actually possible that can be used to attack a guest application. And we also realized that these virtual containers provide a good pen testing environment because it provides a root-like environment on one side. And the next good thing is it avoids the need for patching or re-signing or recompiling a guest application while doing a pen test. So if you see in a normal scenario, right? So you can see this when you do a decompilation of an application. So you will get something like when APK tool may fail at some times also. So this kind of things is not really going to be a hindrance for a pen tester when he is actually executing a guest application inside a modified virtual container. And in fact, many runtime application self-protection mechanisms, which is incorporated in the applications, can be bypassed in such environment. So I'll be talking about 4 different attacks that is possible from a host application onto a guest application. The first one is about the debuggable property of the host application. Normally, all the Play Store applications are not debuggable by default. So generally one has to decompile it, patch the manifest file and recompile it and then use it. So, but in the case of virtual containers, if what we found is if the host is debuggable, then all the guest apps become debuggable too. So once it is debuggable, then you can actually attach Android debuggers to the guest apps. And also we found that ptrace can be attached between guest apps and also from the host app to the guest app and vice versa. So there is no additional step needed for any recompilation or resigning is required on the guest application. So without tampering an application, you can actually make an app debuggable. The next attack, okay, so this is about, so this is just a snapshot about how on a virtual container, the 5 different applications which is downloaded from the Play Store appears here. And by default, we built the virtual application as a debuggable. So all the other applications inside the container becomes debuggable too. So you can possibly attach a debugger to any of these applications. The next attack is about network security configuration. Since Android 7.0, we see that the apps can customize their own network security settings. Normally, you can have a user installed TLS certificates and also a custom certificates which an application believes that can be part of the network security configurations. So this makes sure that if certain CA certificates are not, like a self-signed certificates are not available on the device, it is possible to include as part of the application itself so that that specific application can actually trust that self-signed certificate or any user install certificate. So what we see here is when the host application is built with a network security configuration. So this particular property is inherited by all the guest applications as well. So once it is, once all the guest apps get the same set of configurations, then it is easier to perform man-in-the-middle attacks on all these kind of guest apps inside the container. The third interesting attack is about the Java security provider. So we have JCA APIs provided by the system. So for all kinds of crypto operations and Keystore operations, applications generally use these APIs. When executing inside a container, and if the host application has the flexibility to add a malicious security provider at number 1. So when it does this, all the guest applications which actually depend on the default security provider or unassumingly will start using this crypto providers, and then their crypto will be kind of broken. So here we see that in this one of the as a proof of concept, actually what we have done is we took one virtual container and we took one of the security providers, something like Spongy Castle, and we patched that provider with some logs such that it prints the keys and as well as prints the output. So we inserted that at the number 1 and we tried the same AND OTP application. So when we use this application, you can see that when an OTP is generated, it uses a HMAC operation. So for the HMAC operation, the OTP seed is actually the key, and the output will be the 32-byte value, of which a portion of that will be the OTP value. So this logs actually prints, in fact, the OTP seed itself and the OTP value. So once the OTP seed is leaked, then I think all the host apps can actually use it to generate OTP at will. The fourth attack is about having a flexibility to do a dynamic instrumentation on the container applications. So generally, this virtual apps preloads certain libraries as part of the guest applications. So we also found Frida as one of the very popular dynamic instrumentation tool, and we thought of inserting that into the guest apps and see whether it really works. So for this particular experiment, we took a Frida gadget, which generally works in a non-rooted device. Basically, it can be inserted into any application on a non-rooted device, and you can actually use the normal Frida scripts to reverse engineer or dynamically instrument the applications running. So the host applications here actually can inject a Frida gadget when the container application or the guest application starts to run. So at this point, we see that the Frida gadget is inserted into the process memory of the particular guest application, and you can freely instrument this particular guest application using Frida scripts. So to summarize all the attacks we talked about, so from Android manifest point of view, the permissions is one of the issues, which is generally a security concern, or it's more of a privacy concern for users rather than a security issue. The remaining things is mostly related to attacking an application. So let's say a debuggable property or network security configurations can be used to sniff the traffic or make a particular application debuggable inside a container. So as part of, there is another issues about you can actually list all the running guest applications inside a container. And this virtual container provides a root-like environment because you have access to all the sandbox data of all the guest applications. And the most important thing is about the Android Keystore. So with the Android Keystore, you can access keys which is generated by different guest apps, and any malware executing in the context of in the virtual container can actually use such keys to decrypt the data which is stored inside the sandbox itself. And the next thing is about the Java security providers we talked about, and the dynamic instrumentation of a guest app, which is also possible. So these are not exhaustive list. There can be many attacks possible. One minor thing which we wanted to tell about is Android ID. So Android ID is one of the, mainly it is used for anti-cloning purposes, but we see that even on latest Android devices, we see that it is same for all the guest applications, which is indeed a security concern. So given all these security implications, so we thought of providing mechanisms that can be used to detect such kind of virtual containers. The first thing is about Safetynet. So Safetynet, as you know, is a set of services and APIs which helps to know the device integrity. And this is generally used by security sensitive applications. What we saw that is inside the container, when a guest application calls a Safetynet API, the result is in fact, it says the CTS profile match is false as well as the basic integrity is false. But this is also one good way to detect that you are running in a compromised environment. But not all virtual containers actually support this Google Play services, so which is kind of a negative point. So you can't completely rely on Safetynet alone when executing inside the container. So we are going to talk about 6 different detection mechanisms using heuristics. Here are manifest permissions, as we discussed earlier. The host application has a whole lot of permissions, and generally a guest application need not have all these permissions granted. So if a guest application checks what are the permissions granted versus what is actually asked for, so that difference is going to indicate that guest application is in fact running in a compromised environment. The second detection mechanism is about the storage directory. So normally on Android, you have a flexible common data paths like data, and the package name. But inside the virtual container, it has a additional package name which is related to the host application itself. So you can see when the AND OTP storage directory, it includes the package name of a parallel space itself. So this is also an indication that you are running inside a virtual container. The third detection mechanism is about using a process memory. A container application, when it checks its own process memory, it usually can find only the the libraries loaded by that particular application or the system libraries. But you see a whole lot of libraries or artifacts which is not related to that specific application. So using this also is one of the detection mechanisms. The fourth is about seeing the environmental variables. Generally, some of the containers have some proprietary namings for this environmental variables, so which is also a good indication that it is that you can understand that it is running inside some container. There is one more thing is LD preload. So normally a host application preloads certain libraries on the guest application. So you can find the path of the LD preload to be something suspicious, which is not related to this application. So this is also a good indication that that the application is running inside a virtual container. The fifth is one of the simplest things when you iterate through the running services of a particular application. Usually you will find the running services of your own application, but inside the container, you will see additional services which is run by the virtual container itself. So that can also be a good indicator of a virtual container. The sixth mechanism is about app components. Generally, you can declare some kind of particular component, something like a broadcast receiver as enable is not enabled, like enable is equal to false, and dynamically enable them in the code. But this kind of operation doesn't really work inside a virtual container. Basically, this broadcast receiver cannot be enabled at all when you actually run inside a container. So this is also one of the indications that it is running inside a virtual container. So putting it all together, so we are releasing a Conveyor library. So it is an open source library and it is available in this link, which you can see here. So it can detect the presence of virtual containers using the various the techniques which we discussed already. So one caution that it is actually not tested across many Android devices and it may have some rough edges. So be cautious about using it. So we ran this Conveyor library on different popular container applications. And we found that process memory and storage directory seems to be more consistently able to detect all these containers. So you can really believe these mechanisms as one of the reliable detection mechanisms to be used to detect containers. So given all the security implications, so we have some recommendations for the developers. So at first, do not let your apps run inside a virtual container, because given the security implications we see already, so you may need to increase the cost of repacking your app as a malware. So also do not rely completely on the OS security. You should have your own mechanisms to encrypt data at rest. And for the network configurations, so to prevent man-in-the-middle attacks, you should have your own certificate pinning mechanisms. And if you are really security sensitive application, then you may need to think about having an additional layer of encryption or signing of network traffic. And for the crypto, again, don't rely on the default platform providers like what is available on the system. Rather, you can have your own provider, or you can use directly the crypto APIs provided by Bouncy Castle. So also there's another way that you can use explicit security providers like cipher.get instance with AES and putting a second parameter which is pointing to the explicit provider. So the recommendations are applicable as per the threat model which you have understood for your applications. And we are coming to the discussion and conclusion part. So here, generally, this users should be well informed about the security implications of this kind of application because of these virtual containers. So users should avoid, in fact, using these virtual containers for sensitive applications at least. We see that some OEMs are already supporting it, and if more and more OEMs start supporting such kind of running multiple instances of an app, it will be great. And more importantly, if it is implemented as part of the AOSP itself, it will be even more better. So given all these security implications, we are actually not able to reason why these virtual containers are actually allowed in the Play Store itself. So to conclude, so we see there is a need to run multiple instances of an app on a device. Virtual containers are in fact easy to use, and it solves a particular purpose, but we see that it abuses the Android security model. So we also see that there is a security and privacy concern for all the guest apps which is executing. And we saw that virtual containers can be used as a good pen testing environment. And we see that Safetynet and other heuristic mechanisms can be used to detect virtual containers. So our contribution in this talk is about documenting and demonstrating the different attacks. And we are also proposing different detection mechanisms and releasing the Conveyor library. So I will show you a very short demo. Are you able to see this thing?
Yes, we do see your screen and currently a virtualized Android.
Okay. So we developed an application which is called Conveyor. So this Conveyor is actually mimicking as if what a malware can actually do inside a container application. So whatever we discussed earlier about how normal guest applications can do an attack on other applications. Here we have listed out most of the attacks which we discussed. So here is actually a list of applications which is actually present inside the container, and you can see a zip. So once you press this zip, you can actually have the data of that particular application exported to the SD card, or you can actually export it to a cloud service. The next thing is about seeing the list of running apps. You can see a whole lot of running apps, basically especially these are all in fact running inside the guest application, inside the container. So you can see all the running guest applications inside this container. Next is about the Keystore thing. So we see that, so we can see all kinds of keys, even though this Conveyor app is actually haven't created any keys inside the Keystore, but it is all the keys of the Keystore is visible. And in fact, you can get to know what kind of key is it and what is the alias, what are the algorithms can be used with these keys. And finally, we also show the detection. So we are running inside a parallel space app. So you can actually see the different detection mechanisms which we showcased is actually detected when running inside the parallel space. Okay. Okay, so thank you for this opportunity, and we are looking forward for the questions.
Okay, thank you very much, Gautam and Vikas, for your talk. Sorry for the technical difficulties, but I guess in the end, everyone was able to follow. We are ready for another Q&A session. Once again, you can either use the raise hand feature in Zoom if you follow using the Zoom client, or you can use MetaMost, the Program One Q&A channel. And we actually have a couple of questions already. I try to do them in order. The first one is from Thomas. He asks, do you know if there is a connection to Activity View, which allows to start activities of other applications?
So for starting the activities, they tend to hook the activities which are called. I'm currently not 100% sure if you can start the activities on your own for the other applications. But for sure, when a user starts an activity, you can always hook, and basically it looks transparent to the Android framework.
Okay, thanks. Then we do have actually a couple of questions from Daniel Thomas. The first one, I just read it out loud. The first one is, he says, these attacks are interesting. Could you expand on the threat model? I'm not so clear on the relative danger of different attacks, as some require a malicious host and others only a malicious guest app. How is the host vulnerable to the guest? So it's about the threat model.
Yeah, okay, that's an interesting one. So yes, that is correct that for this threat model, you always require a host application, a malicious one. But then we have seen that there is a tendency for users to use these applications, and you need to believe on these providers that they don't do anything malicious. So firstly, we are depending on the end user that they know very well, like what security decision is to be taken. And if they're using these virtual containers, they don't install sensitive applications. So that is one aspect of it. The other aspect is that of a malware, that once this is installed as a malware, then they can always leverage. They can use the applications which are already installed on these devices to mimic like a real one. So yeah, that's mostly in terms of the threat model. Gautam, you have anything to add?
No, generally, actually, what we see is this containers actually act like a God mode kind of application. So normally, these kind of God mode applications are the general attack points for the malware. So generally, malwares try to attack such kind of applications so that they can gain all kinds of privileges within the virtual container. So typically, it is mostly whether virtual container can be a rogue application, or it can be or a application becomes rogue when it is put inside a virtual container.
Okay, thank you very much. The next question from Thomas is, would it be possible for container developers to improve their faking capabilities of being a real device to guest apps so that none of your heuristics actually work?
Yeah, it is very much possible. So it is like a cat and mouse game. I'm pretty sure if you're hell-bent, thing is open source, so you can always make it look like the container is not present at all. So I think many of us can relate it to rooting of the Android device. Like Magisk hides it so well that you cannot even detect the presence of the root. So it's very much the same scenario.
Okay. One more question from Daniel. If you directly call Bouncy Castle, do you benefit from operating system security updates for the security providers, or do you have to ship updates for your application every time Bouncy Castle ships an update?
Yes, it's a good question actually. So with Bouncy Castle, because it is actually part of your application itself. So that means, so whenever there is a update on the Bouncy Castle, so you may need to actually update your application as well. Given all these things, actually, yeah, I agree that system security providers are up to date, but there are other pitfalls like when you are executing inside a virtual container. So you have to be really careful about, are you really using a system default security provider, or it is a patched provider? So if you are able to differentiate that, then it is good. If you are not, it is better to actually focus, you can have your own set of crypto providers.
Okay, thank you. So we have a bunch more questions, which is no problem because fortunately we are just waiting for the break. William writes into the chat, I wonder how much of the motivation for using these applications is a result of the difficulty of switching between user accounts in Android, similar to the chat heads problem, which is apps doing dangerous things. Android created a dedicated API. Possibly there is a way for Android to associate two user accounts in a way that this is more seamless in the UI.
Yeah, that's what is one of the major point of our discussion as well, that for sure there is a big market. For sure people want it. I mean, from a personal point of view as well, I do tend to use 2 WhatsApp accounts as well. So I feel the need of it. And given the need, the use case, and then you have the example of some OEMs doing it like OnePlus and Xiaomi. If you personally ask me, yes, I very much would be happy if Android can provide such kind of inbuilt mechanisms and which we can believe and use it without considering the security.
Okay, thank you. The next question is from Paul Blundell. He asks if any app can be imported into parallel spaces and thus be vulnerable, or does the app need some special changes in order to work with parallel spaces?
Any app. So we tried multiple of them. So if you see in the slides, we have screenshots for like ride-hailing apps, Uber. We tried some digital apps. They were working as well. With some applications other than parallel space, there could be a slight problem if they are heavily dependent on Google Play services or those kind of services. But other than that, if they are standalone applications without much dependence on Google Play services, they work pretty fine.
Okay. Not so much of a question, rather a statement, I guess, is from Matthew. He says, Google generally recommends not specifying security providers, especially given the built-in bouncy castle implementation is old. Indeed, it should be noted that Play services also provide updated providers to help fix some SSL vulnerabilities. Such patches aren't so possible if you hard code the provider. If you want to add something, please do that.
Yeah, so yeah, I do agree that, I mean, in the first place, tinkering around with the crypto providers or crypto in general can be not so advisable. And I understand the Google's point of view that why they advise so. And of course, the security patches is a problem. But then the recommendations that we have is especially when the threat model requires you to take care of them. So if your applications are sensitive enough and if you have people who are really aware about what they're really doing, especially when tinkering with crypto, then for sure they can do that. Gautam, I think you have something to add?
No, something similar to what I said earlier. So especially if you can really detect that you are using the real, say, system security provider, then it is you are good to actually use a system security provider.
Okay, thank you very much. Okay. Well, next question from Sihang Goi. Are there plans to incorporate virtual container detection into the MSTG resilience checks? I guess this one goes to
I'll take it. So, okay, yeah, that's of course. Firstly, thanks for the question. So yeah, of course, that's in the plan. So I think me and Gautam were really discussing that once we are done with this presentation, we'll take up these topics with OWASP guys and try to incorporate and get their feedback, how we can make it more developer friendly and yeah, get to a broader audience that these are the issues that can be addressed. So yes, to answer the question in short, yes, we have a plan to go for it, yes.
Okay, perfect, and sounds great. So another question from Bernhard Gründling. He asks, if an app uses certificate pinning, we could circumvent this without rebuilding the guest APK in this case. Is this correct? This is part one of the question. And part two is, additionally, we could provide our CA certificate via the host application environment instead of writing it to the system. Is this correct? So the first one is certificate pinning, and the second one is to provide a CA certificate to the host application environment.
Okay, for the certificate pinning, yes. So when a guest application has its own certificate pinning, so yes, you can at least mitigate this specific attack, which we talked about, especially related to the network security configuration. But having said that, it is still not foolproof again. So you can, we also talked about FIDA instrumentation, and also that is also not enough because you can actually hook and bypass your certificate pinning as well. So that's one thing. The second question. Because you want to answer?
Yeah, the second question, it says, additionally, we could provide our CA certificate via the host application environment instead of writing it to the system. Is this correct?
Okay. Actually, this is okay. If you are a guest application, so then this is completely not possible at all, because a host application is a different application by itself. So it's something similar to like you are inserting certificates which that specific application is going to trust. Okay, so it is not really putting inside the system trust store. It is something like a trust store only for that specific application to believe.
Okay, that sounds reasonable. Thank you. So there is one more question from Renee. Please, you're using audio, I guess.
It's been partially answered already. I was just interested in the use case scenarios that you saw those containerization apps to be targeted for. How many of those do you think would actually be easily replaceable with just standard work profile? Or do you think that people use those containerization apps instead of something like multiple work profiles, having more than even 2 instances of an app? Is that, do you see, so considering that work profile is widely available on at least modern devices, and if we could make it easier to not require a large MDM centrally managed and so on, do you think that that might be a replacement for most of the use cases that you've seen those containerization apps used for, or is there anything else missing?
Yes, okay, so yes, for sure. Actually, we also are thinking about on the same lines of managed profiles, which is already part of Android devices. So the one issue which we generally see is with respect to the managed profiles, there is an additional, of course, there is a device admin or an additional set of authentication which is required to move between two spaces. So but in the case of virtual containers, normally there is no such kind of a need for additional another device admin kind of an application or kind of additional authentication which is required when you use virtual containers. So for sure, what profile is almost on the same lines as what these virtual containers are already providing. And in fact, it is more safer to actually use work profiles. Vikas, you want to add something?
Yeah, I think you mostly covered it. So I just wanted to add that these virtual containers just provide the ability to use them is so easy. You just download from Play Store and you use it. I think that's one reason that users prefer to use them compared to, let's say, setting up a work profile. Or it could be possible that many non-technical users sees it as a hassle to set up and do those things. So I think it's also from the usability point of view as well.
Thanks a lot.
Okay, thank you very much. I guess there are no more questions. I'd like to conclude with a very non-technical question. When do you intend to release the Conveyor library?
It could be as soon as tonight. So I just need to clean up the code and just upload on GitHub. So it's all about the last few things.
Okay, perfect. Glad to hear that.
All right. Thank you so much for the questions, and thank you so much.
Thank you all. Thank you very much.
Okay. Yes, thank you very much for this great talk.